Chapter 14, Section 6 talks about how to find the approximate p-values. To do this, you want to use Table B in Appendix C. First, you'll look up your t-value and then go upwards to find the approximate p-value for that appropriate point. To read p-values reported by others, it may be a little difficult, but you just have to pay attention to what they're telling you. So if they say that the p is less than 0.05 or less than 0.01 or 0.001, you want to look at the inequality sign. If it's less than, anything that is greater than that will fail to support the research hypothesis. If other inequalities are used, they are still interpreted the same way. One important fact to note is that it is impossible for a p-value to be zero. That is because each sampling distribution extends to infinity on both sides. For the evaluation of the p-value, there is a less structured approach that you can take. This is if you have a borderline test result. So you would postpone the retaining or rejecting a null hypothesis until you have sufficient evidence. However, the problem with this is that it will be difficult to deal with type 1 and type 2 errors since there is no absence or a firm commitment to your choice. The level of significance for the p-value. Both of them are different things. So the level of significance is specified before the test result has been observed. This describes the degree of rarity that triggers the decision to reject the null hypothesis, while the p-value is specified after the test result has been observed, and it describes the most impressive degree of rarity actually attained by the test result. Chapter 14, Section 7 talks about statistically significant results. That is also called tests of hypotheses and tests of significance. They are described as being statistically significant as in the name. So for this, you can reject the null hypothesis and be statistically significant, and this would mean that the test results can't be attributed to chance. While if you just reject the null hypothesis, it's always referring to the population, and this is because a population is always a fixed value and controlled by nature. So if you say that is just being statistically significant, it's referring to a sample. Statistical significance implies that only the null hypothesis is probably false, and whether it's false because of a large or small difference between population means. You want to beware of excessively large sample sizes. This produces statistically significant results that lack importance and therefore small standard error. But also you want to avoid an erroneous conditional probability. So there's two things that go with this, and it says that the PR, the observed result given the null hypothesis is true, is less than or equal to 0.05. And this is conditional probability, and it depends on the assumption that the null hypothesis is true. And then the other one is the same format where the PR is less than or equal to 0.05, but it says that the null hypothesis is true given the observed result. So for this one, it's reversing the order of the events in the conditional probability. And these two are often confused, so you must make sure you figure out what the 0.05 refers to. Section 8 talks about how to estimate the effective size. There are point estimates and confidence intervals. So for the point estimate, it tends to be inaccurate because they ignore the sampling variability. They identify the observed difference for x bar 1 minus x bar 2 as an estimate for the unknown effect. There's also the mu1 minus mu2, which is an unknown difference between the population means. So for confidence intervals between the mu1 and mu2, the ranges of the values that in long run include the unknown effect at a certain percent of the time. They're not inaccurate because it includes the sample variability, unlike the point estimate. So the equation for this is x bar 1 minus x bar 2 plus or minus the t confidence of s subscript x bar minus x bar. So that just represents the estimate standard error. So when you're interpreting the confidence intervals for this, the numbers refer to the difference between the population means, and you have to make sure you include the sign because that indicates direction. We can't ever be true or false, but can be reasonably confident with these. And a single interpretation is possible only if two limits of the confidence interval for mu1 minus mu2 share the same sign. So that would be both positive or both negative.